Hello students, in today's session of Moving Charges and Magnetism, very basics of magnetic force on a current carrying conductor will be discussed through illustrations. In earlier session we have discussed all these things which you can review on Sethiswiftlearn. In addition to this, I would also like to say NEET 2025 physics paper complete detailed solution is available on website Sethiswiftlearn.com which you can visit there and have solution. इसी के साथ साथ मैं और रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आप YouTube चैनल Sethiswiftlearn के साथ नहीं जुड़े तो प्लीज़ सब्सक्राइब द सेम इफ यू लाइक द वीडियोस एंड कंटेंट्स एंड अपने फ्रेंड एंड कोलीग्स को भी फॉरवर्ड कीजिए और शेयर कीजिए. नाउ लेट्स स्टार्ट विद द क्वेश्चन. ठीक, concept is magnetic force on a current carrying conductor. In earlier sessions, we have discussed Fm equal to Q V cross P. Means when a charged particle enters a uniform magnetic field, it experiences a magnetic force. Direction of this is given by Fleming's left hand rule or right hand palm rule. This is for positive charge. This is for, and that is equal to QVB sin theta. Theta is the angle between V and B. Right? This was discussed in magnetism, very basics 1. Right? Then further we'll discuss path followed by charged particle moving in magnetic field, uniform magnetic field. That will be straight line, that will be circle, that will be helix. All these three concepts were discussed in magnetism, very basics, session 2. Right? Now in this session, I am going to discuss force experienced by current carrying conductor. Force experienced by current carrying conductor. That is given by Fm equal to I L cross P. That is ILB sin theta. Current is flow of charged particles. Flow of charged particles. Now, direction of conventional current. Direction of conventional current. Direction of conventional current is opposite of electronic current. Therefore, they can be considered as plus Q charge. This can be considered as a plus Q charge. Right? Now, L is length vector and generally it is applicable for straight conductor, right? But for arbitrary shape, as B is constant, I is constant, so B into I DL, DL, right? DL. Suppose this is a conductor. This is point A, this is point B. We join this. Current is flowing like this. So ये पॉइंट सी है, ये डी है, ये बी है. Wire section is AC DB. So what will be DL? But DL vector will be equal. DL will be, that is integrate DL will be equal to L, that is distance between initial and final position. Distance between initial and final position. Therefore, here DL will be equal to AB. DL will be equal to AB. Right? For closed loop, suppose in this case, circle current is there, like this. In this case, net force Fm is 0 and torque equal to alpha 0. But if we take a square, suppose this is the magnetic field, this is the magnetic field. Suppose this is the direction of flow, and this is the, one will be this, one will be this. In this case, Fm will be 0, torque will not be equal to 0. To equal and opposite, the line of action will be different. Line of action will be different. Therefore, they will constitute a torque also. Right? In this complete session, main thing is to find DL. DL is generally to be taken distance between initial point and final point of the current. For closed loop, it is equal to 0. Now, let's start with the next question. Question is, in the figure shown, a semiconductor wire loop is placed in a magnetic field B equal to 1.0 Tesla. The plane of the loop is perpendicular to the magnetic field. Current I equal to 2.0 ampere flows in the loop in the direction as shown. Find the magnitude of the magnetic force in both the cases. Concept, applicability and solution. There are two figures. This is figure 1. It forms a closed loop. Does not form closed loop. You know, magnetic force is given by I L cross B, I L B sin theta, theta equal to 90 degrees. Right? Now, case 1. For closed loop, as L equal to 0, that is the distance between initial and final position is same. Therefore, Fm equal to 0. In case 2, in case B, this is given to, so this point is C, this point is C, this is A, this is B. Now, current in the wire ACB and current in the wire AB. In this case, both lengths will be considered same as distance distance between initial and final position is same. Therefore, for both wires, FACB will be equal to FAB. Therefore, we can take ACB, AB means twice AB equal to length, right? Now, therefore, magnetic force will be equal to Fm will be equal to I twice AB into B, that is the 2R diameter, 2 into 2R into B. On substituting the values, we get 2 ampere, 1 Tesla. 2 ampere, 2 into 2 into 1 Tesla into 1. That is 8 Newton. That is the answer. I think concept is clear regarding the L vector and for closed loop, right? Now, I would like to request, if you are new to my YouTube channel, Sethiswiftlearn, please like and subscribe to my channel. Press icon to receive updates on concept killing videos. Thank you.